Lesson 25 is dealing with quadratic functions. We got through a good portion of the lesson last week as we looked at factoring and solving quadratic functions. However, sometimes we're going to be dealing with things in a little bit of a different way, and we need to know what some of the characteristics of it are. The rest of this lesson here is going to actually describe these ideas. So as a review, some of the things we know about quadratic functions are, it's going to give us a parabola or a U-shaped curve. The reason that we're going to know this is going to happen is we're going to have a second degree equation, meaning that the highest power is going to be 2. We'll also be able to determine whether a parabola opens up or down, and that's going to be based off of the a value from the equation. Remember, the standard form of the equation is ax squared plus bx plus c equals 0. A is always going to be with our x squared term, b will always be with the x term, and the c will be the number all by itself without any variable at all. We'll also use this idea as we find the axis of symmetry. The axis of symmetry, again, is the line that actually goes through the middle of the parabola that allows us to fold it over top of itself so it's symmetrical on both sides. In this case, since we're dealing with a quadratic, it'll always be a vertical line. In order to find that, we have a formula, x equals negative b over 2a. Again, b and a come from our standard form equation of ax squared plus bx plus c equals 0. You plug them in and solve, and you'll end up with a final equation along the lines of something like x equals 0, x equals 12, x equals negative 4/3. Use the formula to determine it, and you'll also realize that this axis of symmetry will always go through the vertex of our parabola. And there's also real-world applications that go along with our quadratics as well. Any object that's actually in free fall or motion is actually going to be described by a parabola. Picking up where we left off in the notes last week, example 2 brings us into a situation where we're going to determine if a parabola opens up or down, and then has us finding the axis of symmetry. In part A, we're going to examine the equation and see what's happening here. Well, right away, many of you are probably saying that it's going to open up. And the reason you're saying this is because the a value here is positive. A equals 1. Keep in mind, if we see x squared, that means 1x squared, and 1 is a positive number, making us know that our parabola will open up. To find the axis of symmetry, we use our formula, x equals negative b over 2a. And now all we have to do is determine what b and a are. Well, we know a is already 1, and in this case, b would go along with the x term, and I don't see any x term in this equation. Well, since we don't have an x term there, that means b would be 0. So x is equal to 0 over 2 times 1, or x equals 0. In this case, the axis of symmetry for us is actually the y-axis. If you were to take the equation y equals x squared minus 9 and graph it, you would actually notice that the vertex would actually have the next value of 0, telling us that the axis of symmetry will have an equation, x equals 0. Part B, similarly, we're going to determine if it opens up or down. Right away, many of you will be saying it, well, it's going to open down. And the reason behind this is because a is negative 2. And since it's a negative number, it'll open down. Again, to find the axis of symmetry, we use our formula x equals negative b over 2a. In this case, b is going to be negative 4. Remember to keep the negative sign with your variables. So negative 4 over 2 times negative 2, or 4 over negative 4. Well, 4 divided by negative 4 is a negative 1, gives us an axis of symmetry of x equals negative 1. Again, to double check, you can actually take this and graph this and make sure that the vertex has an x value of negative 1. For parts C and D here in example 2, I'm going to allow you to practice these on your own to make sure you have these two processes down. When you're done, come back and check your answers. So right now, press pause, and when you return, press play on this video. Okay, welcome back. You should have taken the time to actually work on these two by yourself. I'm going to show you the answers now. Keep in mind, I'm not going to be actually showing the work. If your answer does not match up with my answer, go back through your work and see where you may have made a mistake. Remember, one of the most common mistakes that we make is with our negative signs. Well, this parabola is going to open down. We know that because the x squared value has a negative 3 in front of it. And we also know that the axis of symmetry is going to have an equation of x equals positive 1. The second one is going to open up, and it's going to have an axis of symmetry of x equals 3. Finally, example number 3. An object is dropped from a height of 1,000 feet. The equation, h equals negative 16t squared plus 1,000, gives the height h of an object in free fall after t seconds. How much sooner will this object hit the ground before an identical object dropped from 2,000 feet? What we're going to do here is we're going to explore this entire situation. we've got an equation, negative 16t squared plus 1000 equals h, telling us how much time has passed and how high the object would be. We don't have any of that information yet, except, oh, it does say the object is hitting the ground. Well, we're going to take this equation then, the negative 16t squared plus 1000, and set it equal to something. Well, once an object hits the ground, what's its height? What is its height? Yeah, that's right, it's going to be 0. So we've got an equation, negative 16t squared plus 1000 equals 0. Now at this point in time, you might try a couple of things that we did last week in class. You might try factoring this, you might try using the quadratic formula. Those would all be good ways to do this, but you might also notice something. There's only one spot where there's a variable here, and actually, we can work on isolating that variable by solving to get it by itself. We're going to do this by first isolating the term with the t, negative 16t squared, by subtracting 1000 from each side of our equation. Once we subtract the 1000 from each side of our equation, we get negative 16t squared equals negative 1000. To finish working on getting t by itself, we're going to divide negative 16 from each side and get t squared equals 1000 over 16, which could be simplified, or we could just keep working with it like this until through the end. T squared means we're squaring t, so the opposite of squaring is square rooting, so we square root both sides of our equation. I don't have to worry about the plus or minus here in this case, because I know with working with my real-world situation, I'm only going to have to deal with a situation where I'm going to have a positive answer. So from here, the square root of t squared is going to be a positive t, and then the square root of 1000 over 16 is approximately 7.9. That's correct, I rounded it. One decimal place should be good enough for us. And of course in this case, t actually represents seconds. Now we also have to figure out how much earlier it's going to go before hitting from being dropped from 2,000 feet. Well, looking at this equation, we see that plus 1,000 there, and we also know it was dropped from a height of 1,000 feet. Well, if we're dropping it from a height of 2,000 feet, that's going to give us an equation, negative 16t squared plus 2,000, and again, if we're worried about it hitting the ground, it'll equal 0. We're going to follow along with a similar process to solve for t. As we're working through this, again, we're also going to keep in mind that t is going to have to be a positive value. So t is going to be about 11.2 seconds. So now if we just have to figure out how much sooner the object will hit the ground, we just have to find the difference between these times. So our longest time is about 11.2 seconds. The shorter time is about 7.9. As we subtract them, we'll find out it's going to be about 3.3 seconds sooner that the first object hits than the second object. At this point in time, you're now ready to begin working on the Lesson 25 worksheet.